Anthropic just initiated the immediate multi-platform rollout of Claude Opus 4.7, bringing a new frontier of intelligence to developers worldwide. Token context window. However, an updated tokenizer means raw token usage increases by 1.0 to 1.35 times. To compensate, Anthropic heavily upgraded the model's vision architecture, pushing processing capacity to 3.75 million pixels. It easily reads dense architectural diagrams, analyzes intricate chemical structures, and interprets complex UI hierarchies perfectly. Anthropic engineered this specific update for the requirements of long-horizon software development. While previous models operated as assistants requiring constant human prompting, Opus 4.7 functions as an autonomous coworker, working independently in the background. This shift toward independent execution changes the expected standard for how AI agents handle enterprise-grade projects. This autonomy is powered by a structural change to how the model allocates inference time compute, which Anthropic controls through effort levels. This cost-to-performance matrix shows the previous disparity between standard high and maximum max settings, either fast, cheap answers or slow, expensive reasoning. Anthropic fills this gap with the X-high tier. Its reasoning capability spikes upward, while latency remains remarkably low. At this effort level, the model loops internally through reasoning chains, evaluating its own logic and catching errors before it ever outputs a line of text. Anthropic is confident enough in this efficiency that they have raised the default effort level to X-high for all users of their Claude Code platform. They also introduced a new /ultra review command, leveraging this tier to autonomously scan codebases and flag deep architectural bugs that standard linters miss. The real utility here is the economic advantage. It gives developers precise control over the cost of running complex reasoning tasks at scale. This animation illustrates context entropy. As a memory block fills over a long session, it fractures, causing hallucinations. Notice how this fractured memory pollutes the code commit timeline, turning the execution line red. This degradation historically forced developers to restart sessions, killing momentum. Opus 4.7 addresses this degradation through a process called stateful memory consolidation, operating silently between user prompts. During idle periods, the model reviews its own context history. It merges overlapping observations and systematically removes logical contradictions. It then takes vague working assumptions, converts them into absolute facts, locking them into its session index to maintain a clean internal map. Developers can explicitly manage this process using the new Task Budgets beta, which guides the model's token spend to prioritize memory retention during long runs. Anthropic has also extended auto mode to its max-tier users, allowing Claude to make permission decisions independently without interrupting the human operator. Instead of stopping and waiting for input when an initial tool fails, the model uses its consolidated memory to pivot, select a new tool, and push through the problem. Resolving the entropy problem allows Opus 4.7 to execute multi-day autonomous sprints. To test this sustained autonomy in a real-world scenario, Anthropic engineers assigned Opus 4.7 to build a complete text-to-speech engine using Rust. The model generated the entire application from an empty directory, rather than refactoring existing code. This diagram outlines the system: neural model, SIMD kernels, and browser demo. Bridging intense math with the front end was the hurdle. Watch the self-correction node. Opus 4.7 initiated a verification loop, turning red to green as it compared its Rust output to a Python reference. It fed its own generated audio through a speech recognizer to definitively prove its Rust implementation matched the reference Python model. When validation steps failed, the model iterated on its own code, looping through execution errors until it achieved perfect parity. Delivering a verified system of this complexity typically requires months of dedicated labor from a senior software engineer. Crossing this delegation threshold fundamentally alters the developer's role from writing syntax to reviewing finished architectures. Qualitative examples only prove what a model can do. To measure reliability, we have to look at strict quantitative benchmarks. This bar chart tracks performance on Cursor Bench. Opus 4.6 previously cleared 58% of the evaluation, while Opus 4.7 surges to a 70% clearance rate. That 12-point increase translates to solving 3 times as many real-world production tasks, specifically those involving ambiguous documentation and legacy codebases. Next, we look at the GDPVal-AA leaderboard, which measures advanced knowledge work. Opus 4.7 sits clearly at the top with an ELO score of 1753, positioned above GPT 5.4 and Gemini 3.1 Pro. That 1753 ELO score secures a verifiable mathematical advantage over the flagship offerings from both OpenAI and Google in this category. It achieves this score while registering a tool error rate that is a third of previous Claude generations. In 2026, benchmark dominance is no longer defined by static test-taking. It is defined by the reliable execution of multi-step agentic workflows. But the broader market reality is that no single model rules every possible use case. While Opus 4.7 leads in sustained autonomy, GPT 5.4 still holds the edge in raw, terminal-heavy speed, and Gemini 3.1 Pro remains the most cost-efficient choice for massive 2 million token contexts. Because of this, technical teams are moving away from single-model reliance and adopting intelligence orchestration. Orchestration dynamically routes different parts of a software task to the most capable and economically efficient model for that specific job. Platforms like Claude Code handle this routing automatically. They assign Opus 4.7 to handle high-level architectural planning, while dispatching lightweight subtasks to faster, cheaper models like Haiku. Opus 4.7 is natively optimized for the Model Context Protocol, allowing it to orchestrate local files and third-party APIs with 30% less token overhead than its predecessor. Developers and product managers must redesign their team workflows around managing parallel agents rather than prompting a single chatbot one-to-one. Claude Opus 4.7 is the first model reliable enough to serve as the lead engineer in a fully automated software workforce.